Good day, 10A. Last week we discussed about electromagnetic radiation, and you have learned that it is an electric and magnetic disturbance traveling through space at the speed of 2.998 times 10 to the 8 meter per second. So you have learned also that it contains neither mass nor charge, but it travels in packets of radiant energy called photons, or yeah, there's another term for that, quanta. Yes. So, you've learned also some sources of electromagnetic radiation and some of the properties. What you're seeing on the screen is the electromagnetic spectrum. It's a broad range of electromagnetic waves. So, the EM spectrum is classified into types according to the frequency. Try to check on the frequency. What do you notice here? From the radio wave going to the gamma rays. Okay, so what do you notice? In another, we have also the wavelength. Take a look at the wavelength. What do you notice on the wavelength as we move from left to right? Okay, as we move from left to right, what do we notice about it? Okay, so here the frequency is increasing. So these waves here are arranged in order of increasing frequency. Okay, then what else did we learn? Take a look at the relationship of the frequency and the wavelength. Okay, so what do you notice? Okay, so the wavelength is decreasing while the frequency here is increasing. So that's the relationship. What else do we see on the screen? The energy. Okay, these three can describe a specific EM wave. That's what we're going to do. We're going to calculate the frequency of a particular wave because that will define, that will describe what wave will that be. And it is very much associated to energy. Now, we need to review ourselves with some of the properties that would be essential in determining, in describing a particular wave. First, we have the frequency of a wave. Frequency is the number of waves that pass a point in a given amount of time. Okay, so the symbol is F, which is equal to one cycle, one complete set of a wave. Okay, so something like that, no, over second, over time. So 1 over second is associated to the unit Hertz. So frequency is measured in Hertz. Then another thing, what is the relationship between the wavelength and the frequency of waves? You have learned that already. So frequency up, then we have here down. When electromagnetic waves travel through a medium, the speed of the waves slows down. But in space, the speed of the wave is the same to the all EM waves follow the speed of light. Okay, so what else? Wave speed is equal to the frequency of the wave times the wavelength. So we put here multiplication sign or a dot. It is expressed in meters per second or equivalent. Okay. Now, we have here to get the speed of an electromagnetic spectrum, we use the equation as presented a while ago. C is equal to frequency, that is symbolized as V, times the wavelength, the lambda. So V actually it's mu, a Greek letter, Greek symbol mu. Next, we have lambda, that's another Greek symbol for um, wavelength. That's how we solve it. And remember, when you try to solve right using a magic triangle, you try to cover a portion, and then that's it. Okay. So if you're looking for frequency, we have C over lambda or wavelength. And then if you're looking for wavelength, then you have speed over frequency. So we manipulate this equation to solve one factor or one variable from another. Let's have this one. Okay. We had an example of this. So violet light has a wavelength of 4.10 times 10 to the 12 nanometers. What is the frequency? Now, if we're going to solve it, again, as a beginner, and as always, to help you organize your thoughts, we will use the gas form, which is given. Given is meters, that's in lambda, that is 4.10 times 10 to the negative 12 meters. Okay? Then, what is asked here is the frequency. Solution, we show what equation to use. We base it from the previous slide. So we have, we're asked for the mu here. Therefore, we have C over lambda. Okay, so we substitute. Our speed of light is 3.00 times 10 to the 8 meter per second divided by the wavelength rather, that is 4.10 times 10 to the negative 12 meter. Using your calculator, do that. We cancel m because meter divided by meter is equal to 1. And with that, a lot of you were able to give me an answer this morning, and that is 7.32 times 10 to the 19th Hertz. Please take note why it is Hertz, because this is 1 over second. Okay? So, we will express our answers altogether in two decimal places, okay? So that we will have a uniform answer. Is that clear? So, that's how we work on the wave speed equation. Let's have another. We have the green light has a frequency of 6.01 times 10 to the 14th, that's 14th Hertz. What is the wavelength? So, given in the problem, again, sorry, I don't have a space here. So given that is frequency 6.01 times 10 to the 14th Hertz. What is asked here is the wavelength. Solution, wavelength is equal to the speed of sound, the speed of light rather, divided by mu, or the frequency. So we have 3.00 times 10 to the 8 meter per second divided by our mu, and that is, or our frequency, 6.01 times 10 to the 14th Hertz. We convert Hertz, or we change rather it into meter per second so that we can work with the units. We cancel out the unwanted units because anyway, that's equal to 1. And then, oopsie, our answer here is, can you recall? Okay, 5.00, or shall I say 4.99 times 10 to the negative 7 meters, because the unit left is in meters. Okay, so is that clear to you? I hope so. Please try to calculate that using your calculator. I had given this, but this is more of the speed of the sound, or the sound wave. It's either a sound wave or a water wave. Now, let's focus on the next. This is what we call as the energy, quantum energy of the photon. Okay, how was this discovered? Remember that EM waves behave like a wave and a particle. So the particle-like nature of EM radiation manifests an interaction of ionizing photons with matter. So the amount of energy found in the photon is equal to the frequency and Planck's constant. Okay, so which means to say a photon is directly proportional to the photon energy, rather, photon energy is directly proportional to photon frequency. Okay, if you get to see here, this is another way to solve for to express photon energy of photons, that is in that is in electron volts. Okay, that is in electron volts there. So Planck's constant is 6.626 times 10 to the negative 34 joule per second. We will follow this for uniformity of answers later on. We just simply follow this, okay? Do not round off. Use the value. Is that clear? So, again, this is Planck's constant, and this is the frequency of the radiation. Okay? So, as what I have said, this is any of the two that you're going to use. So, what's the purpose of this? The energy of EM, getting the energy of EM, determines its usefulness for diagnostic imaging, okay, just like in the MRI, no, and CT imaging, uh, computer tomography imaging. Okay, so knowing the energy, you get to know also, knowing the energy value of the radiation will tell you about a particular type of electromagnetic wave. Now, let's take a look at this. Here we are combining, sorry, this is um, lambda, okay? So here you're combining, we had used rather two equations already. We had discussed two equations. Let's have a practice on the second equation that I presented to you, okay? As what I have said, um, the usefulness of getting the energy, right? So one way to identify the type of electromagnetic wave, and of course, the amount of energy will determine how it is used in modern science. Okay, now let's have a sample problem. Calculate the energy of a photon of radiation with a frequency of 8.5 times 10 to the 14th Hertz. So given in the problem is frequency, which is 8.5 times 10 to the 14th Hertz. Okay, then you are asked for the energy. Solution for this is energy is equal to HF or HV. Any will do. Okay? Again, V here is a Greek symbol, means mu, and that is referring to frequency. So solution, what do we have? E is equal to H. H is Planck's constant, 6.626 times 10 to the what? Going back, okay, -34 joule time second. Then we multiply it to the frequency, and that is 8.5 times 10 to the 14th. Let me write it down here. 1 per second. We cancel the second. So energy is left. Therefore, can you recall our answers here this morning? I hope so. Or if not, can you please get your calculator and solve? Okay, so we have here, I think, 5.63. Kindly check if I rounded it off properly. Times 10 to the -19 joule. Is that it? Yes, that's our lesson this morning. And of course, I ask you also to calculate on this one and this as your assignment. Okay, and this one also as your assignment. We will be discussing this tomorrow. I hope you've learned something from our discussion 10A. Bye.